faster software delivery and more performance software that we all chase yet never seem able to catch. Delays, glitches, and missed deadlines frustrate IT teams and their corresponding partners. But not today, because we found the right solution that solves team and software performance issues in just 3 months, whenever it is applied. And the key to that secret is your architecture is dead. Well, that sounds a little bit fishy. Let me explain this with a different approach. You were taught the best architecture design in most types of software is this. Typical 3-tier architecture. The presentation tier, the application tier, and the data tier. I happen to have a software that is designed precisely in this fashion. Let's measure the performance. RPS or request per second is a well-known and accepted KPI for software performance. It measures primarily how many users can use the software at the same time, simultaneously. In a 10-core machine with 64 GB of RAM, roughly 120-140 users per second can use this function. Now, let's remove the data layer just for the experiment. In the same machine, roughly 20,000 user requests per second. That is bigger by 2 orders of magnitude, 100-200 times faster. So the only thing we have to do is get rid of the database? Can we do that? Nope. The point I wanted to demonstrate is whatever you do, however you fine-tune the database, the data layer will remain the most significant bottleneck. And of course, we cannot just simply drop it. Then what can we do? We have to split it. Instead of a giant complex database, we are going to line up a bunch of small, simple and dumb databases. Wow, that's awesome! How? Technically, we will split the application layer, the middle one, into small independent microservices, and each of these microservices will have just a tiny simple database for its own purpose. So what is the microservice architecture? And especially, what are the microservices? Microservice architecture is a software design approach where a complex application is broken down into smaller, independent and loosely coupled services called microservices. These microservices are self-contained units responsible for a specific business functions. This style of software implementation promotes flexibility, scalability and ease of maintenance, since changes or updates in one microservice do not necessarily conflict others. More importantly, they can fail independently. When a single microservice becomes unavailable, the rest of the system remains unaffected. They communicate through APIs, messaging queues, and can be developed, deployed, and scaled independently. Microservices enable developers to focus on individual components, leading to faster development, improved resilience, and increased flexibility to evolving requirements. And that's make it a so popular choice for modern software development. In order to maintain this flexibility, there are some design principles you have to follow. Number 1. Decentralization and loosely coupling microservices cannot share data or code. They should be designed and operated independently. This means each service should have its own database if needed and should avoid sharing data or code dependencies with other services. Number 2. Microservices should be independently deployable, meaning you can update, scale, or replace a service without affecting others. This reduces the risk that a single service causes downtime or issues in the entire system. This independence is more important than code reusability. Number 3. Single responsibility principle. Each microservice should have a single, well-defined responsibility or business capability. This keeps services focused and makes them easier to understand and maintain. Number 4. Interoperability. Microservices must communicate effectively through well-defined APIs or protocols such as message queues. This ensures that services can interact seamlessly even if they are developed using completely different technologies. Number 5. Resilience. Services should be designed to handle failures cleverly. This includes a bunch of mechanisms for retrying requests, handling partial failures, and having failover strategies to maintain the overall system reliability.
reliability. Number 6, scalability. Microservices should allow for horizontal scaling, meaning you can add more instances of a service to handle increased load. This is critical if you have a constantly changing traffic pattern.
I can read your mind. You believe all you need is microservices. Well, that is unfortunately not entirely true. You still need to learn two concepts if you want to leverage the power of microservices.